start recording button, and we're going to kick off. So, transistors. Let's switch to black. And I apologize because as much as this graphics tablet is making board lessons much easier, it is a little bit laggy because my computer just struggles to drive it all and do records and do all that sort of stuff. So anyway, we're going to look at transistors, and we're going to look at one specific kind of transistor, and that is called a bipolar junction transistor. And very specifically, we are going to look at one kind which is called an NPN transistor. So bipolar junction transistor, if you ever see BJT, that's what that stands for, right? Bipolar junction transistor. And NPN is just a kind of bipolar junction transistor. Normally, if you hear someone saying transistors, they mean a BJT. And these are a semiconductor. And a semiconductor is exactly what it sounds like. Sometimes it conducts, sometimes it does not. The reason that they sometimes conduct and sometimes they don't is because they're made of material that is called a semiconductor. And depending on how you treat a semiconductor, it'll either conduct or it won't. The way that an NPN transistor works, and by the way, NPN refers to the different sort of parts inside the transistor, but the way that I remember which one a NPN transistor is that it is not pointing in. And the symbol for an NPN transistor looks like this. And there's a little arrow down here, and that arrow is not pointing in. And that's how you know that it is an NPN transistor. So an NPN transistor has 3 legs, and IRL, they tend to look like this. They're a little plastic covered nugget with 3 legs poking out of it. Sometimes, if it's a big chunky transistor, then you might have a big heat sink on the back of it to dissipate some of that energy. Now it's got 3 pins, and those pins are called the base, the collector, and the emitter. So B is the base, C is the collector, and E is the emitter. And the way that a transistor works is that, or the way that an NPN transistor works, right, is that you can have a current flow from the collector to the emitter, but you can only have that when there is a current flowing into the base. So, to put that sort of succinctly, from base to emitter, then from collector to the emitter. And so in this situation, these work like an electronically controlled switch. If there's no current flowing from the base to the emitter, then there's no current flowing from the collector to the emitter. And so essentially this is a switch that is off or open. And that's how I like to think about transistors used in this way. You can use transistors to do heaps of other things. You can use them to do amplification. In fact, all solid state amplification is based on transistors or arrangements of transistors, usually multiple. But for our purposes, we're just going to think about it as like a switch. So
Is it kind
let's
of like
look.
a relay?
It does work like a relay. I mean, in the way that a relay is a switch that you can control electronically. But when you're switching with a relay, you're using electromagnetism to actually throw a physical switch. Whereas with a transistor, that switching is entirely electronic. There's actually no moving parts inside a transistor at all. And there's reasons that that is advantageous in some situations, and there's reasons why you might use, like a relay. But let's look at this example, right? So what we've got here is we've got a 9-volt power supply, and that is connected to a motor. And so the current coming out of this 9-volt power supply would really like to go and pass through this motor and turn it on. This diode you can ignore for the moment, right? So it would really like to go through that motor, and it would like to get back to ground and make that motor run. But it can only do that, right? So current can only flow from the collector to the emitter if we have a little bit of current flowing into this base. And so what we've got here is we've got a much smaller power supply. So we've got a 5-volt power supply here, and it's connected through a switch, through a resistor to our base. And so when we push this switch down, what we can do is we can allow a current to flow through this switch, through this resistor, into our base. And because this point here should be at a higher voltage than this point here, we're going to have a current flow through that base, and it's going to go back to those grounds or those terminals that are at 0. Now, because we've got a current flowing through this base, now our collector can have a current flow through it to our emitter. And so, now that motor can spin, and that's going to turn that on. Now, why this is important, because if you're looking at this switch and you're going, well, couldn't we have just used a switch? Couldn't we have just had a power supply and a motor with a switch in it? You totally could. I guess there's 2 reasons why you wouldn't do that. The first is that if this is a high current motor, then we've got a lot of current flowing through this pathway. And when you connect a switch and disconnect a switch, when the air gap between the terminals and the switch is really small, you can get arcing across those terminals, and that can burn the switch. And so your switches don't last very long. And so that's a reason that you might want a switch with no moving parts, like a transistor or some sort of semiconductor. The other reason is because what you can do with this side, the switching side, is you can get rid of the physical switches, and you can instead use electronic switches. And so you can do things like use a microcontroller or a computer or any sort of like digital or electronic control device to actually make this circuit work. And I've built an example of that in Tinkercad, which I will show you. So I'm going to drop this in, hopefully here, and have it work. We will see. Almost. Try it again. All right. So just let that catch up. So this is the circuit that I built in Tinkercad to sort of demonstrate this. And so what we've got here is we've got a 9-volt battery, and that connects to this top rail on our breadboard. And the negative here is tied into the negative over here, which is connected to our Arduino. I'll often say when we start working with these things that you need to make sure that your grounds are tied together. And that's what I mean. And what that does is it just provides a common ground or a common point that is at 0 volts for everything to sort of work off. And if you don't have that, often things won't work. So that's what I mean by having our grounds tied together. Now, we've got a transistor here, and the collector is here, the base is in the middle, and the emitter is over here. That's not always the same, right? you have to look at your individual actual transistor to figure out which pin is which, but it will say somewhere on the data sheet of the transistor. So let's look at what's going on. We've got power, and that that positive comes out of our breadboard and goes into our motor. And then our wire from our motor comes out and it goes to the collector of our transistor. And then from the emitter, that goes back to ground. And so if we look at our whiteboard, right, that's essentially what we have here. So we have power goes through our motor to the collector and then back through the emitter to ground. So those are the same thing. And to make that work, we've got a pin from our Arduino, and we've used A0 here, and that goes into our breadboard through a resistor and through to the base of our transistor. And so by turning this pin A0 on and off, we can actually make that motor turn or not. And then I've got a little bit of code here. Can wait for this thing to catch up. As I mentioned, very, very laggy. Come on. All right. So Tinkercad has a really, clean little block coding thing that is, I think, based entirely, or might even be directly from Scratch, which is sort of a popular, way of teaching coding. But all we've got going on here is we've got a couple of blocks here, and this one just sets pin A0 to high, so that's like turning it on, keeps it on for a second, and then sets pin A0 to low. And if you run this, then what we should see is when A0 is set to high, this motor is going to spin. And it does. So it spins for a second, and then it turns off for 0.2 of a second. And then, because this is just looping endlessly, it turns on for a second, it turns off for 0.2 of a second. So it's a pretty dirt simple example, right? There's not very much that's going on there that's super interesting. Where that becomes a little bit more interesting is that you can actually control the speed of a motor by, instead of just having this power supply going into the base be on, you can actually turn it on and off really, really, really quickly. And what that means is that it kind of works like a tap that's turned half on, in that it only lets, a smaller amount of total current through. And so that's going to mean that your motor spins a little bit more slowly. So you can control the speed of a motor. The other thing that you can, of course, do is you don't have to have this Arduino being dumb. You can have a bunch of switches controlling it, or joysticks, or you can even connect something to it via Bluetooth or via Wi-Fi, so that you can control this remotely. And once you've got that sort of stuff down pat, well, then what you've got is something that is remote control, or something that you can operate sort of remotely. And one of the things that I've got coming in the batch of gear that's being shipped to the school is a whole bunch of these guys that have inbuilt Wi-Fi and also have inbuilt webcams. So making things like sort of remote control drones that can do footage and things like that is a real possibility. And to control motors and things like this, you use circuits that are very similar, or at least have their foundation in these transistors. And so that's transistors, right? That's the intro to transistors that I think is so important, because they're such a fundamental sort of piece of tech, and so many of the things that you work with, even though you may not realize it, have transistors inside them. And if you're looking to do any sort of systems project that involves any kind of motion of any sort of motor or thing, which I think is probably most projects, then you're using gear that has transistors in it. So let me stop my recording there.